It has come to our attention that a mysterious force is loose somewhere in outer space.
The mysteries of creation are there.
Up in the sky?
Up in the sky.
The moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
Ian, welcome.
Thank you. Thanks for having me.
Yeah, man. Welcome to the OffWorldly podcast.
Yeah, pumped. Off-world.
I saw that you were at that mathematics museum in New York. How was that? Those pictures looked awesome.
It was great. It opened up about, I think, 14 years ago. It was just on north side of Madison Square Park, and had been there for many years. I went there when it first opened there too, but more recently, they moved to a different location, new exhibits, different exhibits, fresher face, fresher look. They were having their opening gala. And I didn't go to the gala because that was for big-time donors. I'm not a big-time donor, but they did have something that they called, playfully, they called the aftermath, as, and it was basically the after party, but you could come and you could see the exhibits and you could schmooze with all the big to-dos there and see the new museum. So I went there and I went around, met a lot of great people, and decided to take some pictures and post it. So that was a lot of fun. It was a nice evening.
It looked like a lot of fun. It looked like the exhibits were very interactive, and you could enjoy it as an adult or as a kid as well.
Math just cuts across so many different things, whether you're a child to whether you're an adult, even if you're a mathematician, you can still enjoy the ways that math sort of creates the world. I mean, one thing I liked in going to this aftermath party is I met somebody who had for a batch of years been teaching math and music. And he basically told me about how you could create beats taking two numbers that were relatively prime to each other. I would have to practice it, but it showed how you could create these beat patterns, just knowing math, and music is structure of math. Music comes out of math. So it was very nice to learn that.
It's very interesting how individuals' thinking and brain patterns work when you combine music.
Yeah. I mean, music resonances. We study resonances. When we do a vibrational test, we're looking for resonant modes in the thing that we're building. It may not be music that you put out on Spotify, but it's music. It's music theory. It's at work.
Yeah, man. No, absolutely. Speaking of things resonating, I think this is a perfect segue kind of into our show here today. You and me, we had first met a few times over the last couple years, mostly at the New York Space Happy Hour events and Space Week out in New York, Empire Space and Evan Lerner and the crew.
Yeah.
And, I thought to myself, I'm like, hey, this guy seems pretty popular. He bakes cookies in space. He wears glasses. He's got to be intelligent.
I got to be something.
I'm like, I want to know him better. Well, Ian, for the folks who don't know you, Ian Fichtenbaum, he sits right at the intersection of space engineering, entrepreneurship, and finance, and somehow you make all of it seem very easy. He's a space entrepreneur, an advisor, an investor with experience spanning spacecraft builders, subsystem providers, human space facilities, broadcast and communication networks, and the finance work that helps these companies scale. He's the co-founder of Zero G Kitchen alongside his wife, Jordana, where they built a kitchen in space and commissioned the oven behind the first ever food baked in orbit through cookies in space. He also led across the industry as CEO, running Bradford Space in New York and I believe in Europe. And that was with supporting propulsion systems that
Yep.
have been flown across, dozens of spacecraft.
Yep.
But what we're also here to talk about today, Ian, is your main focus right now, which is building a new company called SpaceRig.
Yep.
And SpaceRig is the first space logistics and transit network that's focused on spacecraft processing, testing, responsive space operations, the kind of, let's say, ground side capability that helps missions move faster and more reliably. Ian, thank you. Well, again, I just want to welcome you to the OffWorldly podcast.
Thank you.
Quite a resume you have here.
As we say, we go out every day and we try to do something, and so sometimes it amounts to a story.
Absolutely, man. And so maybe we could start with just a little bit about, where you grew up, where you went to college.
I grew up, well, I'm in New York, so I have a joke that I tell when people ask me, especially when I'm in New York, and people ask me where I grew up, and I do this playfully, but I'll always say upstate, and 80% of the time they say, "Oh, we're upstate," and of course the joke is Montreal, and it's like, oh, that's very upstate, and it's so upstate, it's a different country. I grew up in Montreal, spent first 25 years of my life in Montreal, and spent a small amount of time, just over a year in Vancouver, and then came to New York in 2008. I guess.
Well, that's why I like you,
Yeah,
because you're from Canada. I
yeah,
mean, come on.
yeah.
Montreal, one of my favorite cities. I think you also went to McGill
Yep.
University, right? Yeah.
McGill, top college in Canada. Great place, beautiful views.
Yeah.
Right by the mountain, great friendly people, and tough professors.
I was there, so I was in Montreal for the Space Ops conference last May. I never really toured the university before, and I did a little tour that weekend and went to the engineering department. I think it was actually graduation weekend, the same weekend that conference went on, and yeah, it was just incredible to check out that university. It's got quite a legacy.
It's the jewel of Montreal, but I think the thing with Montreal is they have such incredible universities there. I mean, it's got one of the highest populations of students per capita of any city in North America. So there's a great student vibe to the city, and I think that plays into the whole, the whole Mile End Plateau kind of vibe. Is this, you always have like a very creative studenty energy, and to the layers of people who have come to that city over the many years and decades.
How was it when you first came to New York? You were done with school by the time you came over? Did you continue education?
I was done with school, finished up with my grad studies. That was what brought me to Vancouver. I had kind of a 2 years where I was doing a bunch of stuff. That's when I went to International Space University, was doing consulting. That was my first dip into the space and satellite world. I spent a summer in London for reasons I still don't really understand, but I spent 3 weeks there to learn about econometrics. And I don't remember much of the econometrics, but I did have a good time. And so what was interesting is that those were the years leading up to a rather momentous year in New York history. Of course, I didn't know it at the time because I came to New York in 2008. And of course, anyone around at that time understands that was a time of a lot of tumult in the market, and in New York, markets matter. Boy, do they matter. But I actually got there. There was, not to revisit the whole history of the financial crisis, but there was this whole rolling period from the early fall of 2007 until the big Lehman Brothers crisis about a year later. So I got there in that year where things were kind of rolling. People were very uncertain of what was happening. I would not say I had a front row seat. Maybe it's a bleacher seat. I was in a internship in a little corner of a corner of a corner, but I was there when all the stuff went down, the Bear Stearns, all this other stuff, and then Lehman Brothers. Again, I was the corner of the corner of the corner of things, but I was sort of like there and got the vibes for whatever for what those were worth.
Because you also have a finance background as well, right? So that's kind of where that all started.
Yeah, well, it's sort of like I had always the passion for space, and I studied engineering. I did engineering. For whatever reason, my head was not that of an engineer, which just sounds sort of nuts for somebody who went through 4 years. But I wanted always to do business, but I was one of those people who favorite subject was always math. We talked about math was favorite, engineering. I really got into space policy when I started being on online forums, so just reading online forums. So I kind of always wanted to go in that direction. So I did engineering. I did what was called management science, which was sort of like what you study if you wanted to combine math and business. And then I just wanted to go do business, but also a passion for space. And so, like, how do I go do that? And so it was kind of like this shot in the dark. You want to make it, go to New York and find your fortune. And the crazy thing is that it sort of worked. I guess I can't say it did work, because I went to New York and I got a job kind of doing that. And just before things really went to pot, as they say, in the markets, and I found a little niche of a niche in 2008 to be part of, and that's how I got here. I basically got a job advising satellite and aerospace companies to do financial transactions, or to analyze financial transactions, or anything of that nature. And so that was finally the hook that I got into. But that's probably I did International Space University, the lifelong passion, but I really would not have gotten into the industry like I have if not for that first entry.
Yeah, that's really interesting, because everyone that I talk to in the aerospace industry, a lot of individuals come from different backgrounds, right? So you came from this sort of finance background, and then found the intersection of space and engineering, it seems.
I didn't really come from a finance background. I came from engineering, and operations research is not, it connects with finance, but it's really about, it is about operations and decision making. But finance, especially in New York, is a bunch of things. Where I ended up was really kind of an advisory role. And so everything that I ended up using as the tools of my job, I ended up having to learn. I had to learn how to read financial statements and to do financial modelings and to do valuations. I may have done a course or two, but I didn't really learn it. So I had to learn it. And I had to learn it along with doing my job.
Thinking back to like early in your career, what did you think the space industry actually was when you first entered it?
My interest and passion in space goes from an early age. But I, like many other kids, read like the space books and knew all the planets and all that kind of stuff. My real entree is, and I alluded to this earlier, is this is mid to late 90s, everyone was getting online and Usenet groups were still a thing at the time. And I just found in one of the groups, sci.space.policy, I'll just name it. And it was just a whole bunch of these geeks and passionate geeks who wanted space development and would talk endlessly about launch, the different kinds of launchers and different kinds of things that you could do on the moon. There are different ways to get to orbit, different ways to bring down the cost. So they were having these same conversations then about launch cost and launch rate. But at the time it was, this was late 90s. So you had two things going on. You had basically NASA policy, which dominated and would continue to dominate policy the next at least 2 more decades. And then you had emerging commercial activities. So it was always very interesting to watch some of those early commercial ventures, people trying to do launching, people trying to do satellite projects and constellations. And that was like the first, that's considered like the first commercial bubble. You know, seeing what we all the things that happen now, it's kind of like almost seems quaint, but that was the era of teledesic and iridium. First iteration of iridium. Iridium's now still around and pretty strong, but it's all these things came from the late 90s, and I was kind of watching that. I was a student, a kid at the time, but I followed all that. And fast forward a bit, because you had that bubble, you had all that stuff, and then you had the trough, and a lot of trough of disillusionment. A lot of things went into bankruptcy. A lot of things, you had guys who had leased the Mir space station, and it deorbits into the Pacific. So you had those like inklings of what you could do, but then you had like the trough. You had the crash, and so then that took a whole bunch of years to get through. I got into it myself professionally in 2008. Now, everything was still recovering. It still was the trough. Going into it in 2008, I then was learning what satellite business was all about, because that I hadn't really learned that much. And I came to know that, okay, there's a whole business of leasing transponders on satellites and ground systems and communications networks and telematics, providing email and communications to crew at seas and all sorts of stuff. And it was important. It was prosaic. It was infrastructure. Some of it was very profitable. And that was the basis of some of the main companies then. They're still around. They're in slightly different form, but Intelsat and SES and Eutelsat, those were the ones that dominated. So that model, I came in 2008, so I had to go learn that model. I got to know who makes different dishes, who makes different networks. That's what the satellite industry was at the time. You go to the satellite.
That was the space industry. Those dominant play. I mean, you could even argue that today, a majority of the space industry is still those types of providers, right? That's a majority.
Yeah, it's still. I would say now, especially with Starlink, that the model of satellite communication as it was. I picked 2008 because of when I started, but that model of satellite communication, which had been since the 60s and 70s, it's now been disrupted because of the Starlink, the LEO constellation model. But that is one of a number of things that have changed in that time frame.
Yeah, that's incredible. I was born in the late 80s, so when I was younger, during the space shuttle era and the dawn of commercial space, I wasn't yet old enough or in tuned enough to really understand it, but it seems like, you got a little bit of a jump, frankly, not only being part of these groups online, but then being thrown into it during the financial crisis, getting a taste of space and then making a career out of it now. It's quite impressive.
Yeah. So I did that from 2008 until about 2014. And most of what I was doing was either helping companies buy or sell other companies, mergers and acquisitions, or to a small extent, and helping them find financing at that time. It's a lot different. I mean, to some extent, venture hasn't changed much, but the appetite for space has changed enormously. Space was such an oddball class of things to invest in it in that time period, and I'll probably get to that shortly. But I'll also say that another thing that we were doing is we were just playing advisory. So we would do valuations on electromagnetic spectrum, or we would advise government agencies on just how to promote the space economy, and a bunch of stuff in between. So that's what I did from 2008 to 2014.
Did you notice any patterns early on, in those early years that turned out to be true about the space economy?
The thing about this industry is that it's always searching for an end user. And that's true today. Space fascinates so many people, and we have to sort of remember there's something we call the space industry, but space is not an industry. Space is what we call the whole rest of the universe, or at least when we talk about an industry, we talk about the usable part, whatever you call that, or Earth orbit, maybe slightly beyond. So it's a place, it's a domain of operation. It's not so much an industry. You could basically take any industry that you can think of and just put in space right next to it, and you say, X in space, and there's either something that's very well developed or something that people are imagining in space. The thing today is that a lot of people are going after all sorts of stuff that we've just been thinking about, and they're attracting a lot more capital now because launches are far more frequent, and it's
Cheaper.
It's a bit cheaper. It's more reliable. Launches don't slip anymore, and the reliability has gone way up just because we're launching so often. Or put it more specifically, SpaceX is launching more often. Let's do a shout out for Rocket Lab on that too, because they're launching a lot too. But
Absolutely.
yeah, absolutely. So the launches are happening more often, and that means they're more reliable. It's less likely that they're going to have a failure. So you're not clenching your fists or your teeth when you're seeing something go up.
Yeah.
It's real
It's exciting now.
exciting.
You're rooting for it. You almost know that it's going to be successful. What fails more now are the payloads,
Oh yeah, yeah,
not the rockets.
yeah.
Yeah.
Yeah, and that's a consequence of just experimentations. There's so many new things that people are trying, and they're trying to do it in new modes, that things are failing faster. But that's isn't there somebody who says fail faster? I mean, that's what the industry is doing now, because there's no other way to do it. I mean, you won't get there unless you try. And you'll spend a lot of money doing it, but that's the process of investment and expanding the envelope of capability.
Well, you made an interesting point earlier about, always looking for that end customer and understanding who that end customer is.
Yeah.
And historically, that customer has been the US government, right?
Television subscribers, or businessmen going around the world wanting communications, or ships at sea, or people wanting intelligence from imaging satellites. That's been the big ones. And now that we're doing so much more in space, now it's okay. You want to go service other satellites. You want to go look at other satellites. You want to go beyond Earth orbit. Well, the government's usually paying for that. Some of this, there's a little bit of commercial to commercial going on, a lot, but people are trying to tease out. People think about people in space, and that's now happening more than it was, because now you have Dragon, and so now people can go up, people can pay to go up, and so it's that's that's also why they go up, whether they're going for the experience, or they have something to prove, or eventually will be doing manufacturing.
Yeah, the manufacturing piece kind of excites me.
Yeah,
It seems like I feel like we're still at a point where every commercial company is also waiting for other commercial companies to be successful, right?
yeah.
So we could kind of sell to one another. But I think in space manufacturing, if we could start producing satellites rockets, spaceports, building, right? All of that in orbit, data centers in orbit. That's the new big trend now,
That is the
right?
big one. My link that's my LinkedIn feed all day. Data centers in space.
That's huge, right? If
Yeah.
you look at what's happening now with artificial intelligence and data consumption, it's so much more cost effective to power these projects in space using space-based solar power, using the thermal, cooling that space offers to keep these data centers operating properly.
A lot of that is just betting on space componentry. They're betting on that it just becomes more abundant because space, it's amazing how space, which is like the entire rest of the universe, but it's so different from doing anything here, right here on Earth, in our little atmosphere, at standard temperature and pressure.
We
We're
could
not,
easily test it. We could
we can
easily,
easily
yeah.
do everything right here in gravity. We're so used to that. That's all of our industry there. And the moment you step out of that, everything changes. Everything you got to do changes, and you gotta test it for your thermal, for vacuum, for microgravity in some cases.
Yeah,
It's being hit by micrometeorites. It's by radiation, by
right. Space
atomic
radiation.
oxygen, by all the things. All that space is trying to kill you, and it's trying to do it to your spaceship too. So, yeah, all that you got to do. And so, like just think of like the electronics. How many billions of people, billions of units of phones and appliances and toys and cars, that's all just on the ground. And compare that to the supply chain to support things in space. It's minuscule. Things have changed a bit because even 10, 15 years ago, the quantities of things going to space were they were in the hundreds, but just compare it to like even aviation, like the number of planes, the number of big passenger planes. I don't know the number now, but if you had asked me 10 years ago, the number would be 1,100 single and double aisle planes manufactured by basically Boeing and Airbus a year. Now, a whole bunch of more smaller aircraft. I guess it's probably in the order of maybe take another order of magnitude when you think of all the smaller planes and military and all that. But that was itself an order of magnitude greater than space. And that is small compared to the vast supply chain for everything else we build in the world and the economy. So there's still very much as we're putting a lot of investment in it, it's still very much a niche with a lot of room to grow.
Well, the other piece of this puzzle is the infrastructure side
Yeah.
of things, right? How do you bring all of these components together efficiently, right, effectively, to meet the needs of these customers and do so in a way that is profitable yet also cost effective for the end users.
Yeah.
So I want to zoom in a little bit to kind of what you're building right now, because that feels like it's at the intersection of operation, infrastructure, getting missions ready fast, right? And that's SpaceRig, right?
Yeah, it's like having been part of a number of space system manufacturers. Every time, well, they all have certain things in common, and they all have certain costs that are big, or they're big, especially when you're starting up, and they have long lead times, and it's special expertise. And it's the specialized equipment. It's the thermal vacuum chambers. It's the vibe tables. It's the special test equipment. It's the special things that can handle the spacecraft. It's the expertise. It's like it's its own little world, and there's only so much expertise out there. And in a time of expansion, there's pull on that expertise. So it's kind of infrastructure, because you could call it manufacturing, you could call it processing, you can call it testing. But it's all the things like you want a mission, and from the time you want that mission, or you want that satellite, or you want that set of satellites, to the time it's even ready to go up to space, it's a whole bunch of things. So what's kind of happened is that launch is much more abundant, and it's operating almost every day. There's a launch, but now everyone has to figure out how to match that cadence on the rest of that process, from the time you want whatever it is you want to go to space to the time it's ready to go to space. And so that's what we kind of set out to solve as much as we could. And there's it's a problem-rich environment, because it's a whole bunch of things that either based on current ways of doing things, or what was the volume up until 3 years ago. So I'm actually right behind me. It's my wall. We like to put our favorite things, some of our favorite things, on the wall. This is what we got started with, because basically the U.S. Space Force paid us to build it. But that's basically, we saw a little niche of a problem, which was to put fuel into the satellite, not in space, just on the ground, but put the fuel in the satellite. And people think that's just like going to your pump at your gas station, and it's not. The propellants are different. The tank is very different. You can't fuel it the same way. It's going to space, and it's the lightest it could possibly be. So it's the most fragile it could possibly be. And you want as much as possible, and you don't want to drip on the asphalt. That's not going to fly. So the process of just putting propellant into a satellite has been a big to do. It's not like the rest of it. It's days. It's not months, but it is days, and it is a process. And we set out to say, hey, what if we could do this better? What if we could automate it, make the interfaces better? And this is what we built. This is we call I guess we weren't very creative with names, the automated propellant loading system. Because you think of a snazzy name for it, I'm happy to hear it out. You could tell I wasn't obsessed with the name. I was obsessed, one, that it worked, because you want.
Yeah, you want it to work.
And you want it to look good. And I was obsessed with it looking good. But that was part of the function. So I won't go into too much detail, but you can see a few things here that we wanted. One, of course, it's the 2020s, so it's got to be digital. And so you see there's a touch interface there. And yes, you can operate it remote, and that's part of how to operate it in a more responsive way. Just all the interfaces, everything that plugs into this is all in one spot. We just made sure that it was all in one spot. It's design. It's not
now,
doing magic here.
How did you make those compatible or universal with satellites, or what? Because this was specific to the Space Force, you knew what you were building going in.
So just meant for one particular propellant, or one particular class of propellants, which was for a long time one of the most used and one of the most problematic, which was hydrazine. So this is designed to handle hydrazine. People are using all sorts of propellants now. The hydrazine is still well used, and handling is still an issue. And once we knew what propellant we were handling, the next thing is, what tank is it? And the good news is that there's two, you could say three really types of tanks out there. And then there's just interfaces, and most of the interfaces are either you can make yourself compatible, or you're really not far from making yourself compatible. You're an interface or two that you order on McMaster or from some other places, not McMaster in this case, but for a few interface providers, you're not that far from being able to basically plug into anything that most everything that the industry is building.
How did this need first come about? Did you approach the Space Force? Did they approach you?
Space Force was running a challenge called Tactically Responsive Space. So the whole notion that we got to do space faster. There's a few different ways to do that, and a lot of attention has been about how to maneuver in space faster, how to do things in space faster. But they're also interested in getting launches ready and prepared faster. We came at it from that direction, and some of the stuff just seems prosaic, but it's real time. So I won't go in that much detail because this is public forum, but Space Force has had circumstances where their infrastructure is not going fast enough. It's not meeting the time frames, and they don't have that many good ways to solve it unless they're solving it infrastructurally. So that this hit on a couple of things that they needed just to make that time frame. It was designed first for that, but it was also designed where you're just going to have a lot more of everything, a lot more satellites, more propellant, more anything. And so just think about what the infrastructure is now and what it could be in 5 to 10 years. That's all got to expand. So building something like this is kind of anticipatory.
So when you talk about responsive space as a service, responsive in practice essentially means how do we move from weeks to days to hours in this process?
Yeah. And actually the context changes depending on whether you're government or commercial. The commercial has this issue as well. They may not need to go to days, but some of them are having to go from years to months or something more reasonable, and they need to solve that too. And especially anyone who's trying to get into the space industry from whatever their components they make or whatever they do, and they want to build out a space capability. And so that comes with that means infrastructure, means expertise, it means ways of building these things. And so how do you get that on the timelines that everyone is going at? How can you almost instantly get space capability? And so that's what we started to think about the SpaceRig and just what are the things that people need. And it's testing, it's manufacturing, it's supply chain, it's pre-launch processing, it's all those things. So what are the things we can do next? So the next thing we tackled was testing. And testing. So testing, there's everyone's basically got to do because it is the vacuum of space and it's a harsh environment. And those things they're thermal vacuum, TVAC, they're vibration, they're atomic oxygen. There's a number of different things, but those first two are the big ones. And so I guess it's first of a kind. That's a thermal vacuum chamber in a shipping container. So one of the most common things to move from place to place, very common logistics. Wherever you go in the world, shipping containers are on trucks, thousands of shipping containers on ships. So the global economy runs on shipping containers. And there you have not just a shipping container that's, bringing it to site to install, but ready to go. And so that's, you really could call that kind of a lab in a box, that it comes to your site or it's ready to go if you want it there longer term or an extended term. So that's and the reason we talk about that is that it's not just a thermal vacuum chamber, it's a workspace, it's a lab clean space that you can have your testing capability and you can have a work environment. So it's inherently for building a space that it's there, that it comes prepackaged. So we also think about that as responsive space. Is like how do you as a commercial company, it could be government, but it's mostly commercial, have space capabilities. And this one is comes to you as a package, essentially ready to use. And so that's another piece we're proud of, because it's building blocks. We're you see it as, how can we solve this building block versus this building block?
Well, it's solving something that traditional facilities can't. You're no longer having to bring your spacecraft, your satellites to those facilities.
You're bringing the testing to them. I mean, and it's getting like, so it really is hitting kind of that spot, because everything people are building is getting bigger and more complex, and every time those things get bigger and more complex, it becomes a bigger to do to send it out to a testing facility or to get a testing facility. When we're talking about mobile or modular, there's a limit to how big we can make the test facilities. We cannot make the larger thermal vacuum chambers. We cannot. We're not putting those on a shipping container easily, not unless they're in parts. So
Sure.
this
You're not
model,
putting James Webb into right.
not in our formats. James Webb had to move when it went out to launch, and that was a whole process. Mad respect for the people who did that, because that you don't want to be, I don't know how many billion, that was a many $billion instrument, beautiful, exquisite instrument, doing wonderful things. But to be in charge, to be the person in charge of moving it from wherever they built it in the US, they launched it out of French Guiana. So just to do that trip and not have anything happen along the way, this is mad respect for the people who did that.
And you're now doing that at a much smaller scale now, from a transportation perspective.
Yeah, that's where we want to go, and that's where a lot of our thinking is going. Being able to be that transportation. We really have to get into that flow, and so we haven't gotten into there yet. But ideally, somebody needs a streamlined service from the factory to the launch pad and a number of things in between. And so if we're properly serving that, then yes, we're doing that transport. I have to be careful, because there are transportation companies that are licensed, DOT licensed in the US, that do that. We're not looking to be that kind of company, but the physical infrastructure that they haul from one place to another, providing that for all these new sort of commercial companies. And yeah, that's one of the areas that we want to be players in.
How did you obtain funding at first? Was it applying to grants? Was it self-funded from your previous ventures?
It's a little bit of everything. This is what we call bootstrapped, very bootstrapped up until now. When we set out to prove something infrastructural, and I think we're now figuring out what the pitch is that we're getting very excited about, and people that we're talking to are getting excited about. So that's helping. But we started off with infrastructural elements, so it was very bootstrapped. We won a U.S. Space Force contract in tactically responsive space. We proved that. We also were able to use funds that we raised from people I know, my own funds, to get the mobile TVAC started.
With the TVAC, like, were you able to take a lot of commercial parts off the shelf, or did you have to kind of build things from scratch?
So mad props to the people who built it. I didn't do the building. Some of it is industry standard. Some of it from getting non-space builders to learn how to do things for space. So there were suppliers there that had to learn how to build certain the key things, and I would say they did a great job. But it was a learning experience for all of them. And it's a learning experience for us, because learning what's the main mode that people will use this. People are still very much either they have their own TVAC or they send it out. So we're breaking new ground about the notion that the TVAC comes to them. So what's actually happening is, I think what's interesting is most people still will be sending it out, but we'll have some cases where it makes more sense to send the TVAC to them. What the split is going to be, whether it's 60-40 or some other ratio, we don't know yet because we're getting our legs on this.
What about universities? Do you see a lot of opportunity
Yeah.
there?
Well, that is where people want to train, and people want to, they want to get experience on equipment. That's one way to do it. They either they can go out to a test center, or you can bring the test center to them. Now, some universities do have test centers, but many do not. And this is a great way for technical schools or universities to get their hands on, or just have something right in front of them. And that's something we're looking at right now.
What about internationally? Are you looking to, to expand internationally? And is there is there cost efficiency in sending these processes and products abroad as well? Or does
So,
the cost of getting them there outweigh the benefit?
so there is such a thirst right now for, they call it sovereign capabilities. And it's partly because of the growth of the space industry. It's partly because geopolitics and so many middle powers want their own capabilities in so many different areas, and space is one of those big ones. I mean, this security that you have or not have from controlling or not controlling satellite constellations and positioning and timing systems and surveillance and reconnaissance has really waken up a lot of people out there about the importance of this. So we're seeing it a lot, seeing it in middle powers. A lot of them are NATO allies that are wanting to build their own capabilities. You're seeing others out there in the world. We're here in the U.S. We want to support allies. We want to support capabilities in friendly countries.
Are there ITAR restrictions
There
with
are
any
ITAR.
of your? Okay.
There are ITAR restrictions. What they apply to or what they don't apply to, it's not something we're going to talk about in an open forum, especially not being a lawyer. But they're there, they exist. But people also export. An export economy doesn't exist if you're constantly, you don't know what is, what isn't. And so, there are export, and then there's that there's tariffs, there's other things going on right now. So I feel a lot of this can be worked through. We're just starting, relatively speaking, relative to where we want to head. And so there's, we're keeping ourselves here in the U.S. from Canada. So we're doing some things in Canada as well. But we always make sure that we're doing things properly.
Well, you picked New York as the HQ. Why base it here? In New York, in the States. How do you see that kind of fitting into the ecosystem?
Well, New York is where I am. Some things happen because some places you're where you are for your reasons. It's family, it's love of a city, just where sometimes it's inertia, but this is where I am.
Yep.
And so it's quite a city. I don't know if for as much as Empire Space has been promoting, I don't know if I could call it a space city yet. But there's certainly more and more people interested. Maybe they're interested financially, which I get. We're all here. We all have some of that, but we also have the passion to build. So yeah, I'm here. The company we built out some capability. Build capability out in Seattle. Seattle has a rich really ecosystem of talent. It really builds more satellites there than anywhere else in the world by far. Actually, even if you back out Starlink, I think that's still the case between Kuiper and so many other activities there. But Seattle is, city number one for building satellites, but there's so much because of the legacy of Boeing and Boeing being there, and Microsoft and Amazon and all the space companies that have gathered up, a lot of them around Kent, around Blue Origin, but all over there. So we have the facilities there, and so we do a lot of development there. But we're also looking at other places to do the development because different places have different expertise.
What's your biggest challenge or blocker right now?
This is the biggest blocker right now. I wake up every morning and I think about that, and so I don't know if it's different every morning or I focus on something slightly different each morning. But all business is either it's customer, it's delivering to the customer, it's finance, it's team, it's positioning. Hopefully, I don't spend so much time doing that and just or getting things done, but it's some combination of what is it today? I think because we have a couple of products / services now, then now we're trying to execute the first steps on not the first steps, but the first real commercial steps of that and make way for what comes next. Because we really want to get into that whole rest of that sequence. We want to get into the manufacturing. We want to get or helping manufacturing. We want to get into the other parts of the test chain and the supply chains. It's just a rich trove of opportunity there. And so it's one thing at a time, or it's three things at a time. And that's what I'm trying to care about right now, SpaceRig.
I'm assuming there's other areas of the business that you're looking for help in, or you're looking to hire in.
Anyone who's involved in developing ground systems or operating test systems are friends of us, or will be friends with us, or I hope will be friends with us. We're also, you can't go anywhere these days now without AI, and I don't even know how to even grapple with it, because now anyone can use AI. You just get a pro account on Claude or any of these agents, and the moment you make the first prompt, you are using AI. So you can be a user. To be a deployer is another real question. And we think there's a massive opportunity to deploy AI in what we're doing. And we're getting our feet wet right now in that. That all areas is wild. And you don't even know what's next. But what I think AI does is that allows you to dream in a way. You can dream in all sorts of ways, but you can dream in a way that's productive.
A focus, yes.
Yeah.
If you can focus your use of the technology, like anything else.
Yeah. Because what is a product? It's or service. It's a set of things that satisfies people's wants, and it does it in an efficient or at least productive enough way. And so if I want to do something, I want to build a satellite. In this case, our head's on that because we're in this, but I want to do that. So where does AI play a role? I just think of a couple of dozen or more ways that AI can be involved in that whole process. And having worked with engineers of all sorts and knowing their pain points and the things that they've wanted, how do we match that to what AI can do? And I think that's a huge opportunity right there.
How do you think it's gonna impact the industry, the workforce as a whole? Is there a fear that the technology, like everyone says, is going to replace certain roles, or do you see it more as an aid, as an accoutrement to the need of engineers?
I think the only honest answer I can say is I don't know. I don't know what the world looks like in 10, 15 years in a change in technology. I can say that people always want and always finding things to do. And that's always been the case.
It's hard to predict the future. I mean, I think that as a commercial new space company or an entrepreneur, I think it gives you a lot of power to get started with a business. To your point about all the things it can do for you, from helping develop a business plan to a marketing strategy to budgeting, an Excel spreadsheet. You can create agents
Yeah.
for each
Yeah.
task and role.
Yeah. So I, as much as I say I don't know, the only thing is have no fear.
Yeah.
Have no fear.
It's like any new technology. You can't think that it's the end of
Yeah.
times.
Have no fear. Be the best person you can be. Build for the world, or build for your family, or build for your community, whatever it is, what it means deepest to you, and have no fear. We've come a long way, and there's a lot more to do, and a lot more we can do. There's a lot of things that the world needs, and a lot more infrastructure, and a lot of things to build to have, so that the world can have what it needs. And history hasn't ended.
Yeah, that's true. It's only the beginning, and if space is really the final frontier, as they say, I don't see it as the final frontier. I see it as like the start of a new frontier.
Yeah, yeah.
Yeah.
It's a new frontier where, by the way, as far as we know, we can't get around the speed of light. So the moment we go to Mars, there is a 5 to 20 minute delay built in to dialogue, and that breaks everything we think about the modern world about. So the moment somebody is at Mars, they are in a 5 to 20 minute moat of information.
And that could be a lifetime in
Yeah.
an emergency situation.
Oh, sure. Not that somebody's going to come from Earth or from Mars back to do them, or maybe it's information, but you're going to have your information pool, your sandbox, literal sandbox in the case of Mars here, and a sandbox over there, and people will be transferring sand back and forth, but it's it has to go in the shovel in the bucket and walk over 20 minutes.
Yeah, no, I mean, I think it explains a lot about the universe, and the sharing of knowledge and information, right? If
Yeah,
there was a faster way, maybe that information would have been shared with us already, and maybe we would have been, farther along than we are.
yeah. Well, again, it's it's talking about physics. So far, we haven't found a way around it, and I think it's beyond this podcast to speculate. I say we leave it at that.
Absolutely. So you guys were awarded this tactically responsive space challenge, or space works award.
Yeah.
Can you talk a little bit about that? What the challenge was and how?
Well, challenge was demonstrating that we could do a setup, a fueling, and a teardown faster and more automated than what is currently. We weren't trying to make magic here. We were just trying to advance the state of infrastructure.
Yeah, it's interesting. What when you think about like what winning looks like for you guys. I know we were just talking before about, hey, we can't predict the future here, but what do you see the future of space logistics looking like? Is it these processing nodes like near launch sites? Is it more mobile test assets? Is it a full integrated logistics network? Where do you see it going?
You want to talk about on ground or in space, or both? Because they're both.
I would say both.
Yeah.
Yeah, we got to start on the ground, but you're right. Space logistics goes into the space as well.
Yeah. Well, you have these nodes. We call them ports. We call them spaceports now, where things go to space. And so, there's got to be a lot more room to do processing, to do fueling, do the checkout, charging, pre-launch integration, handling of propellants and gases. Every one of these sites needs more of that And this is after a long time because where they hadn't needed that extra capacity because somewhere like the Cape was built for Apollo. It was Apollo years, so they had that whole big need then, and then the shuttle, and then for a while they had extra capacity. Well, that's changing now. They need more capacity because there's so much activity now, and that's not going to stop. There's going to be more traffic to space. If we are now we are just about to pass the very critical mark, which is one launch per day, but on average from the entire Earth. I think it was 316 launches last calendar year, and that was a great increase from the previous year, which was a great increase from a year before that. It is an extremely good likelihood this year we are passing 365. Yeah. Now, by the way, that's worldwide. That's not just SpaceX. It's Chinese. It's Rocket Lab. That's everyone. But that's a milestone. That's an exceptional milestone. You know, it doesn't stop. There'll come a time where there's a launch on average every hour, for all sorts of reasons. Or we're launching bigger rockets, Starship and New Glenn and other things are launching. So there's just a need for capacity, and more people are just going to want to be part of building. And that's why I think the whole idea that any space company any company could be a space company if they wanted to. And how do they do that? And so we'd like to provide the tools by which they can do that. Now we have to get out there and build more and get this out in the world. So I'd rather have that do the talking. So keep watching us.
Absolutely. Well, all this SpaceRig talk is making me hungry, which now I
know where you're
want to
going.
talk about
I
these
know where you're
chocolate
going.
chip cookies.
Yeah, I know where you're heading now.
Zero G Kitchen, man. This was honestly
So
the first thing that I learned about you, and it really intrigued me.
let me
Because
just.
not only am I a
We
fan
have
of
this.
chocolate chip cookies.
It wasn't on the wall, but this is basically.
Oh,
Here's the oven. Well, it's not the oven. It's a
I know.
picture we mounted. A picture of the oven that we mounted so we could bring it to schools and just have it to show.
Wow.
Here. So I don't know if I get that. Have that little, and then you can see.
Yeah, we can see. We'll throw some photos.
Well,
Up
some
too
photos
over
into this.
Yeah.
I'll put it.
Where you got to tell me though, where did this idea of baking cookies in space first come from? Was it a joke? Was it a serious idea?
Sometimes couples when they get married, they want something to do together. I mean, besides getting married and start and build a household and all
I
this
hear
stuff.
you, man. You're just bored one night and you're like, yeah, we should just bake some cookies. Let's do it in space.
It was inspired by some things, but the main thing to know about how we sort of got from point A to point B is I had spent a lot of time professionally and maybe even my own enthusiasm with a company called Nanoracks. If you know them, they've been folded into Voyager Technologies, but they were one of the pioneers in making use of the International Space Station accessible. So they got their start in around, I think, 2009. And the central idea is like the CubeSat made satellites accessible to schools or just developers or startups. You could have the same format, but for experiments on the space station. And so here you can make a cube lab and it can go up to the space station. Now, they had to also figure out what were the transportation logistics and how that get marketed. But they were the pioneers in getting access to the NASA manifest. So that around that time, or actually slightly around that time, cargo ships started going up to the space station. And so NASA had a manifest that could go on any number of these cargo ships. And so there was beginning of a logistics train. This was during my banking years. I got to know them because, like any other company or any startup, most startups were looking to raise money and to expand. And I, remember I said at the very, very, very beginning of this talk how when I was just a student going through the Usenet groups, and I remember the Mir space station was leased, and it was private, and it was commercial, and then, of course, it got deorbited. But the person that they had brought in at the time to lead that effort, I didn't know him at the time, a fellow named Jeff Manber, led that effort. And then he came back in to the space industry or into the space station business, be more accurate, through NanoRacks. And he came in, and so this was kind of like when we sort of got connected through our banking business. This was kind of like we get to try to rebuild what I, as a younger lad, was, I was admiring the audacity of leasing a space station. But here, space station is not there anymore. Now there's this international space station. Now we have a chance to rebuild piece by piece. Here's a cube lab. Let's bring accessibility to any schools.
Absolutely, it was game changing.
Yeah. So that I always loved that business because it was building and it was successful. I was even an investor in it. That's how much I believed in it. And we raised them a couple of rounds funding. So I got to know them very well. And just fast forward to my wife and I not only meeting, but getting married. And she comes from a number of backgrounds. She comes from city government, but also working with hotels and restaurants and books. So hospitality was in her passion. Space was my passion. So it was inevitable that we were going to find a way to cross that. So
That's awesome.
Yeah. So when we got into the idea, we approached, I knew who to go to because I knew who had been making the logistics app for the space station for so long. So I went to NanoRacks and said, can you build an oven? And the answer was not yes. The answer was, oh, wait, I think we already built one. Somebody decided to take one of the cubes and put some insulation. Right. So we took a cube, they put insulation, one of the standard ones that they take up to the space station, and they even baked cookies in there. And they even tasted it. They probably shouldn't have because the insulation was kind of melted.
Probably not healthy.
It was yeah. But they said, oh, we already did it. So look, I knew them, and I knew, in the process of kind of thinking of how to do this, what would it take to do this? You try to think of what is the biggest obstacle. And my guess was that the biggest obstacle was going to be getting clearance from NASA, because I knew they already had access to the logistics train. I knew that they knew how to build for the station, and they knew how to interface with it. It was just getting the clearance of, here's
the paperwork.
Yeah, it's the paperwork. It's not really the paperwork, because you can always go through the paperwork, but on the other side of the paperwork, there is someone who's having to say yes or no. Mm-hmm. And so you always have to sort of anticipate, how is this going to flow through whatever the things. So NanoRacks, they had a record of being able to do that. And so to us, it was a no-brainer. And so then it was a matter of, we started the company, we put them on contract, and because we wanted to have an oven, we wanted to build a kitchen in space. And so then and we wanted it to be credible. And in building something to be credible, you got to get started. It's got to be done by somebody who knows what they're doing, and a path to when it's going to happen. And so we had to put all those in motion. And then our question was, okay, how are we going to how we're going to pay for it, how we're going to make money from it, what are we going to use it for, what's it going to do? Is it just, it's one thing to develop an oven, what does it do? And so then we said, okay, then we put the New York marketing noodle together, figure out what actually was my wife's mother who came up with the idea, suggested.
Okay, I love it.
The DoubleTree chain of hotels. They give you a cookie when you check in. So why don't you offer to take their cookie up to space?
Genius.
And when things are never too early. Things are never too early. And this is a lesson, because I remember getting the suggestion, and at that time and at that moment, the best way to get in touch with brands was to go to their Twitter account and to tweet at them. Yeah. This was 2018. And this was just when SpaceX did the Falcon Heavy launch, where they put the Starman on the Roadster.
Yep. And send them out. Yep.
It was around that time. It was huge excitement. And so we said, okay, let's pull up the DoubleTree Twitter account. And, it's timing. It's lo and behold, we see they had tweeted already that, hey, Elon, can you bring our cookies up to space? Well, on your Roadster. They had already tweeted that.
You were late.
Well, that's the thing. I remember this. I don't remember if I was sitting or standing. I was being there by our table, and my instinct was, we're like a few weeks a bit too late to pitch this. And then I said, the heck with it. And from that moment, my instinct was, whatever you do, however way you try to interact with them, do not seem fake, seem as real as possible, because this is first impression. You're trying to tell them something. They're already seeing something incredible. Elon sending the Roadster. And now I'm telling them, hey, now we're actually going to bake them from people you never heard of. But we tweeted back. And at those times, you were just grateful that,
you even got noticed.
Something about the universe has smiled, that the right people were on the right side, and they knew how to respond. And they did. And we went to DM, and then we went to email, and what was very helpful was that DoubleTree is part of the Hilton Corporation, and Hilton has their headquarters in McLean, Virginia, which happens to be also where NanoRacks had an office in Washington, D.C., but it's all in the D.C. area. So, the thing that we wanted to, as I said, I told you at the beginning of this, the thing you don't want them to think is that this is nuts and this is credible. One of the first things we suggest is, if you're interested in this, come to NanoRacks' office in Washington, D.C. It's a nice short drive, under an hour, and meet us there and see what they've done and see what you can do. And we agreed. We did the meeting. We headed down, and this is marketing. Wife and I, Jordana and I, we actually dressed in chef's jackets, and we brought them cookies.
Shark Tank style.
Yeah. We brought them cookies. And then, of course, the picture. We had to show the picture of, on the space station, they have the cupola, which is the big window, the faceted window. We showed the picture of the cupola. We showed the cupola, and we superimposed a couple of cookies in front of the window. It says, we can give you that picture.
Before AI.
Before AI. We can give you that picture for real.
That's wild.
And it was the people who came were basically the people who ran the Twitter account, and also some of the marketing. But they went back. They said, this is real, and they wanted that picture. And so that it took a few more meetings and a little more jumping through hoops. But but that's business. And before we knew it, we were we had not only already gotten this started, we had it's Hilton. It's Hilton. If you watch Mad Men, there's this.
Doesn't get much bigger than that.
Yeah.
Yeah.
You watch Mad Men, there's this scene where Conrad Hilton is having a conversation with, what's the name of the main character? I'm sorry, I'm blanking on that.
Don Draper.
Don, of course, Don Draper.
Yeah.
He's talking to Don,
John Hamm.
and he's saying, "What about the moon? Don, I asked you, there's going to be a Hilton on the moon." And that actually,
That was a real
that was real. It was actually his son, Baron Hilton, who in the late 60s put out that we're going to have a hotel. We're going to have Hiltons on the moon. And in that window of the moon landings were happening, they got that excitement, but certain reality of the time kicked in because the space industry didn't continue. So to have Hilton then revisit that history and have a way to do that in a way that enhances their brand, and doing it in the funnest way you can possibly think of, chocolate chip cookies, it's hard to resist that story.
It's an incredible marketing story.
It's a great story.
Wow. So it was a bit of luck, a bit of perfect timing, and the technology arguably already existed. So it was just really putting those pieces together.
Yeah, it was getting over the hurdles, getting over this technology. You had to figure out how to bake something, drawing the power we could draw. You're drawing 87 watts from the space station. That's a light bulb. Yeah, and so you have to figure out how to bake a cookie with that. But the lack of gravity worked to our favor because we were just using conduction for the air, and the whole idea would just migrate. The heat would migrate to the center of this cavity we engineered. And that is the most basic heat transfer modeling you can do.
Did you have to lock the cookie down so it didn't move and stick to one of the heat modules?
Each of the cookies was in a silicone pouch. So, and the pouch was itself framed. We would call it the tray, but it was also a frame. So it would be a silicone pouch, but it would be bound within a rectangle. And then what we would do is that we take the pouch in this rectangle, this aluminum framing, and you'd slide it into the oven, and then you'd close the door. And so that's how the food item would be in the middle of this, and it wouldn't move around. But of course, there would be steam because you're baking it, and so you had to have vents, filtered vents on that to deal with that.
Well, now I just saw something. I think it was the Chinese who were baking chicken wings in space.
Yep.
So is that next? Are we gonna cook some chicken wings now?
I hope so.
I don't know. It looked a little AI-ish to me, that video.
I'm not sure if I can comment on that, but it looked like
it was
where
cool.
you would take it if you were evolving, if you really wanted to do it for a wider variety of food. So you could have built it to create convection. You could have built it to draw on more power if you had more power. You could have built it larger. So there's all sorts of things you're doing, but we were trying to prove our first point. It was the first thing.
Yeah. What is the long game? Do you want to develop something further now, or is it more for educational purposes?
We kind of, because this came around the pandemic and a lot of things I had to be focused on Bradford, and then standing up SpaceRig. That sort of took priority. And so Fuji Kitchen has been it makes everyone smile. The need is so obvious because the more people go into space, they want food. People need to eat. That is the basis
the
of
reality
reality of life. And so you talk about space logistics. That's space logistics, delivering and preparing food.
That's it. Well, when the first hotels get built on the moon, we know who we're coming to for our in-suite cookie baking oven.
Yeah.
That's a really cool story,
Yeah.
Ian. That's incredible.
Yeah.
Yeah.
It's and what I'm just surprised just how much it resonates. Um, because you try to think of one thing over another, and when I'm thinking about testing and manufacturing on the SpaceRig, my head's on that. And um, I've gotten into pitches, whether it's business or investor, and they find out later that, oh yeah, I was also involved in this cookie going to space. And I'll get, why didn't you start with that? Yeah.
That's true,
What?
but hey, sometimes you got to leave those things for people to discover on their
Yeah.
own.
Why didn't you start with that? Why didn't you tell me that you were behind you were part of being behind
I would have
putting the
said
cookies?
yes 2 hours ago.
Yeah, exactly. But it's the reaction is actually, there's no one that I've met that didn't find it the coolest thing ever. And that's because it is. And so
Absolutely.
yeah,
Yeah.
and self discovery that you did something cool, and people also think it's cool.
It's an accomplishment for any entrepreneur.
Yeah.
And even, the fact that it was something that went into space is even a bigger achievement, because not many people get to build things, but they don't get to send them to space.
Well, now actually I can go above and beyond that, because 3 of those cookies came back to Earth, and I can very well tell people that one of those cookies, where to find that cookie. One of those cookies is sitting in the National Air and Space Museum, Smithsonian Museum by Dulles Airport,
Oh, wow.
in the space food exhibit. So,
That's
it's,
incredible. So they were able to preserve it
yeah.
and keep it as a,
Yeah,
wow.
and as an exhibit in the Smithsonian. And so it's,
Wow, not only did you go to space, but now you're in the museum.
now we're in a museum. It's like, and
Wow.
so yeah, that's kind of wild to think about. That a cookie, you like cookies, cookies are good. One cookie you were involved in is not only in the museum, in the Smithsonian,
Yeah, the museum.
the museum.
It's incredible.
Yeah.
A big part of what I'm trying to do with Offworldly, the podcast, and sort of this STEM resources hub, is showing people that, like, there isn't just one path to space. And I think this is a perfect example, right? You could take a passion and interest in an area, something as simple as hospitality or food service,
Yeah.
and you can combine that with
Yeah.
engineering, and there's your pathway.
Yeah. Yeah.
Some people
Yeah.
come through engineering, some people come through business,
Yeah.
but some through these totally unexpected lanes.
Yeah. And following what we did, NASA started the Deep Space Food Challenge, and that got dozens of teams involved in the challenge of
I've read about that. Yeah, that was for also growing food in space, if
growing
I'm not
food, preparing.
mistaken.
Yeah.
Yeah.
We actually we approached it a little differently, because we weren't trying to do research the same way usually you do research, because we wanted to be able to just accomplish the thing. And
Yeah.
we also had, we didn't want to develop new food. We just wanted to take some common food item and see if it baked differently in space, and how it baked differently. And that was it. That was our goal. I mean, commercially, we were providing a branding exercise for Hilton. That's
Yeah, that was what you were
that was
giving back
yeah,
to them.
yeah,
Yeah.
yeah. So, we came about it, and you can't say it was very successful, because we flew it to space, and we got it done. It happened. So, but there's a lot to do. There's a lot to do in food preparation, food preservation, and preparation, um, and logistics. And I don't follow it all, because there's just a lot. There's just a lot to do, and I think this is a frontier, because we haven't had a lot of spaces in space. What I mean by that, habitable spaces in space. And we have the International Space Station, the Chinese have their space station, but we're really just starting to know about how, quote, normal people will live in space. Normal meaning not, you know,
Yeah.
astronauts who have gone for years and years of training, or professionals, the people who will go for visits. Um, who knows what they'll do?
Yeah, there's a major need for that,
Yeah,
for, training and educating future generations for space travel,
yeah,
right? Like you said, even if
yeah,
they're not astronauts.
yeah. Just thinking about the fixtures, just the living environments, and what they're doing from day to day. How are they? How do they? You know, either be productive or have entertainment, or just interact and have create communities.
Yeah, it's interesting. I watch a lot of sci-fi films where they show glimpses of that, but it's always taking place like on the spaceship already, right?
Yes.
They're like future generations are already born into that lifestyle where they're learning
Yeah.
from an early age, and I think that's also one of the things I'm trying to build with my STEM resources hub, is showing these different sets of skills that arguably you're going to need if you're going to participate in building the infrastructure of space, or the next generation of life on another planet.
It,
You're going to need basic
you're
skills,
gonna
right?
need.
You're going to need basic electric skills, woodworking, first aid. Well, everything goes back to basics.
Yeah, there's so much, and yeah, we only touched on this, and people have had experiments. There've been. We don't know this until we do it, until we have the infrastructure. So that's in space. If there's anything that's going to be something to look forward to, aside from data centers in space, it's just how are more people, how are communities going to be built in space?
I want to send chickens to space. I want to have a chicken coop in
Chicken coop.
space, because you're gonna need eggs. Eggs are life.
I mean, handling of animals is going to be a big deal. I mean, we've not brought, we have not,
Yeah. Outside of bees and monkeys, right?
yeah,
I don't think we've brought.
and the monkeys were all very early on. Really, since the 60s, 1960s, we really haven't brought anything bigger than like small rodents,
Right,
small
mice
mammals.
and
And
lab
so,
rats.
you know, let's say people just want to bring their house pets with them. We there,
Yeah,
we know many people that are very partial to their dogs or cats, and that's the thing they'll think about if asked to go take a trip. So will they be able to bring? How do we handle? How do we
you're
handle?
you're giving me some
Yeah,
ideas now that I don't want to talk about, because I think they're good ideas, but we might have to talk about this.
yeah, yeah.
I want to close with a session that's kind of for the viewers. For someone who's switching careers into space from an adjacent industry, or maybe a student who's fresh out of school, what is your advice for taking that first leap?
Like any other industry, it's kind of a community. It's gotten bigger, but it's still a community. And so somebody really wants to get into the space industry, either find a way to go to some kind of conference. Could be a SEDS conference. It could just be whatever is happening locally, wherever you live. Try somehow to just meet with some people. If you live somewhere where there's a lot of aerospace, find a way to get a plant visit somehow. People always want to show their cool stuff around, and tend to curious people. And so that's always sort of a way. Engineering will never be They always want engineers, but there's all sorts of different roles in this industry, like any other industry. So even if your passion is law, or it's writing, or it's journalism, or it's architecture, or it's just building, working with your hands on, well, that's also engineering, but some of it is technicianing, and it's craftsmanship. Craftsmanship is about maybe the better way to put it, because some of the technicians I know are just some of the best craftsmen that you will ever find. And it's actually interesting to see, it's kind of the difference between the engineers and the craftsmen, technicians, and how they approach building. It's quite interesting to see.
It's funny you mentioned that, because I was recently watching a documentary on the Dodge Viper, actually, of all things. I'm
Yeah,
a big car guy, and it was the newest edition, or the last edition, of the Viper that was remodeled,
yeah,
I think, from like 2015 to 17. And they were talking about how they brought in the best painters, who the cars were all handmade, and the painters who painted them individually painted the cars one by one. And they had all these painters from all over the world come, and they said, it's kind of like no two cars
yeah,
were alike, and you couldn't get the level of detail and craftsmanship
yeah.
that you could with, something else.
Well, I'll add a different, something similar. It's not quite craftsmanship, but it's also something I actually remember from a movie. And I don't know if you saw the movie Ferrari, which played about a year ago. And
Yes.
there's this line in the movie that I just keep remembering, where Enzo Ferrari is being asked about different kind of combinations, deals he can do in business, and he's asked about McLaren, the British sports car company, and he says, "No, we are nothing alike.
Yep.
They race so they can sell cars. We sell cars so we can
You
race."
can race. Yep.
And I keep
That was
thinking
that
about,
was an incredible
yeah,
line.
it was an incredible line. I keep thinking about that, how that just like view of the world, just view of
Your
your
brand,
brand,
yeah,
your
what
life,
drives
your
you.
life view comes from that. You didn't want to build cars. He wanted to race,
I wanted to
and
race.
he just built because of that. It
Yep.
wasn't a marketing thing for him. It
Nope.
it was the thing.
Yeah, I think that's just really good advice in general, that maybe, you should look for your thing,
Yeah,
and then through that
yeah,
you may discover that you're good at something
yeah.
else. What about like information overload? That's something that I face in this industry. It's like, I'm interested in so many different things. How do you pick a lane?
I think this is advice for everyone now, because I think a lot of people are doom scrolling, and this is beside the point of engineering and profession. It's just information is coming from every darn place, and not to be a theoretician on this. Look, you're passionate about something, you'll filter everything else out.
Yeah.
You'll find a
Yep.
way.
You'll find a way.
Yeah.
No, I think that's really great. What about for someone who's coming into this industry? Is there an underrated job category or niche that you think, like, hey, this is where you should focus, or you should start looking, because it's going to open up?
Like, I can't answer that properly because everyone is different. I'm going to do a shout out to friends and very close collaborators up in Canada who saw that there was a need for technicians, actually, test technicians, or just technicians. They started a training called North American Space Institute, NASI, just to start training that workforce. And they've gotten a lot of pickup on that. So that's something that just comes to mind. But I think there's a lot of different things. And the greater quantity of stuff that goes to space, the more just things there are to do, and they're everything. Space is, as I said, as I started, space is not an industry; it's a place you go to do things, and It's a different place. You have to build a different way, but it's a place you go to do things.
And I know we're coming up on time here, so I don't want to keep you too long tonight. But when we're talking about building things, right? You've built across hardware, operations, finance, right? What is one, let's say, execution skill that matters most?
You got to know when one of the reasons why you want to hire the best and the brightest people you can possibly can is so that they can tell you what to do or what you should be doing, because you don't have all the skills. You are never going to have those skills, and especially as you get bigger, you need to have the more of the smartest people come and work with you as possible. One of the things I've been very glad is that I have worked with some extraordinarily smart people, extraordinarily accomplished people. Somehow, some way, they wanted to come work with me. I've always been glad that I've had some exceptional, the people who built this this exceptional engineer. People I've worked with are, in my earlier company in Bradford, exceptional engineers, beautiful production. They just do a lot of production. Then we brought in some people who had built more spacecraft systems than you can possibly imagine, and were able to set up factories that did things that you never thought could do in the space industry. You never go wrong by hiring the best people you could possibly find.
I think that's really good advice. Thank you, and I really want to just thank you for taking the time to meet with me to tell your story. If there's one thing you can kind of leave listeners with, one sentence about building the future of humanity in space, what would it be?
There's no better time to start than now.
That's great advice. Well, thanks again, Ian.
Thank you.
I really appreciate your time, and we'll be sure to share out some information about SpaceRig, about Zero G Kitchen. This way, folks can get a hold of you if they want to partner or collaborate, or hey, maybe come work for you in the future. Yeah.
Thank you.
No, thank you.
The secrets of the past, they hoarded. Now we just boarded on our futuristic spacecraft. No mistakes, black. It's our music we must take back.